This is Mark Storr, Tech Service Rep with BSF, and today I wanted to talk about spraying equipment with Engenia herbicide. We'll be talking about our EngeniaTankMix.com website, discussing proper nozzle selection, boom height, travel speed, and coverage. Here's a view of the EngeniaTankMix.com website. We're going to be talking about nozzle selection today, so one of the first things we need to note is the box down on the right-hand side of this screenshot, which lists all the available nozzles that are approved for use with spraying Engenia herbicide. All the approved nozzles in that website have gone through a series of wind tunnel tests to make sure that they don't produce fine particles. As you can see from this image, in this case dirt particles, move a long distance, and this is just a nice visual to show how far small particles of 100 microns or less move through the atmosphere. Here's a photograph or a slide showing the 5 different approved nozzles that are on that website. So you get an idea what they look like. I just would point out the 2 at the bottom, the ULD 120-04-05 size, and then the TDXLD 110-03s. Both of those have pressure restrictions on them. So that would be the key if you're planning on using those nozzles, is you're going to be limited to the amount of pressure you can spray through them to produce the optimum spray droplet size. I always get questions about what nozzle size I should use, and that's a difficult question to answer. You really have to look in some technical information from some of the nozzle manufacturers. Here's an example of a nozzle breakdown for 15-inch tip spacing on your boom, and these would be 3 different approved nozzle sizes: 03s, 04s, and 05. For example, the TTI nozzles are approved in all 3 of those sizes. So you notice in the center column there, I picked a 10 mile per hour travel speed, and I've noted the delivery volume in gallons per acre for each of those 3 nozzle sizes at 40 pounds per square inch pressure. So you can see the 03 is delivering a 11.9 gallons per acre, the 04 15.8, and the 05 19.8. Realizing that we need to apply a minimum of 10 gallons per acre with Engenia, obviously all of these nozzles fit that parameter, and you could go faster. For example, in the 04, you get up to the 14 mile an hour category. You can kind of interpolate in that chart. Your 40 psi would still be delivering an 11.3 gallon per acre volume. So you get an idea of these various size nozzles here will give you flexibility to operate at different speeds. Here's the same slide, only in this case we're looking at 20-inch tip spacing across the boom. But I got the same 3 nozzles, the 03, the 04, 05 nozzles represented here, at a 10 mile an hour travel speed, and looking at the output in gallons per acre at 40 psi. Now you see the 03 is on the small size. At 10 miles an hour, we're only going to be delivering 8.9 gallons per acre, which is below the 10 gallon per minute or per acre requirement for Engenia. So if we wanted to use this nozzle, we'd have 2 choices: either decrease our travel speed or increase our pressure within an acceptable range. And generally, we want to see these nozzles used between that 30 to 60 psi range is where the best pattern is going to be delivered. The 04 size nozzle is still fitting the parameters. The 05, again, exceeds our 10 GPA minimum, but that gives the ability to be more flexible, either dropping your pressure slightly or increasing your speed. No matter what size of nozzle or type of nozzle you end up going with, we need to keep in mind that the maximum boom height that we can operate is 24 inches. And this will allow us to get the best coverage of those nozzles and also minimize the risk for off-target movement. It's also important for us to understand temperature inversions, because we know that we cannot spray Engenia in very calm conditions when inversions are present. Inversions are common on nights with limited cloud cover and little to no wind. They generally begin to form as the sun sets and will continue through the morning before the surface starts to warm. Their presence is often indicated by ground fog, smoke not raising, dust hanging over a road, or even the presence of dew or frost. They generally will dissipate in the early morning hours once the sun comes back up and we see about a 3 degree Fahrenheit increase in air temperature. So what happens if we spray an inversion, we have increasing air temperature at the surface of the earth, so warm air rises, we know that, and it basically converges with a layer of cooler air because the atmosphere cannot hold heat very well. There's nothing there to retain that heat. So in the loss of temperature throughout the day, we see this cooling effect, and so there's this layer, which we call this inversion layer, where our spray particles will get hung up and they neither fall nor raise, and they're subject to even a light wind that can move them over long distances and create drift problems. The general rule of thumb, if you want to avoid inversions, is to avoid spraying in the evening hours or throughout the nighttime hours, and then wait until you see some warming in the early morning hours. Be sure to double check EngeniaTankMix.com for additional information on approved tank mixes, and also consult the Engenia supplemental label, which assesses the how, which includes things like sprayer setup and operation, and also the when, decisions that you need to make at the time of application. Thank you for your time, and if you have questions or need additional information about Engenia herbicide, please contact your local BSF representative.